So let's do a practice. Let's find one from over here. So how about, let's start with the basics. Do some practice problems. Seems to be right and nice for now. We'll see how it goes. Okay, how about we start with this one? 3 square root 10 times 4 square root 10 also. Okay, so we'll just do one of each to see how we go. How do we solve a problem like this? What are we going to do first? Anybody? This says multiplication. What do we do? It's okay to be wrong. Just take a shot. Bueller. Peanut gallery. Okay, Ava, what are you thinking? No. That's a good guess, though. I would put everything to one big thing. So I would multiply the 3 and the 4. So what's 3 times 4? 12. Okay. Since we combined the big numbers, let's combine the underneath numbers. So since they're both under the radical, we're going to actually do 10 times 10. What's 10 times 10? So then we write it. So now 12 is just a number. We just ignore it for right now. You first ask yourself, is this a perfect square? It is. What is the square root of 100? 10. So this turns into a whole number, doesn't it? And then we already had the whole number 12. So what's the only last thing I have to do to simplify this? Multiply them. And the great thing about when you multiply by 10 is you just literally add a 0 at the end. So for this one, the answer was a whole number. It's 120. Do one just like it. We're just going to change the underneath. Okay? So anytime you have two separate ones with radicals, always just make them one, then try to work from there. I'm going to give you another twofer. And that's one problem. How about 6 square root 5 times 2 square root 15? So what are we going to do first? Yep, combine them. What's 6 times 2? Ironic. Then what am I going to put under my radical? 75? So now leave the 12 alone and we want to break down 75, yes? We can do it any way we want. We can factor tree it or we can just do it. This one I would factor tree it because I know 5 works. 5 times 15. 5 is a small number. 15 is 5 times 3. How does the factor tree method work, Ava? That was me, sorry. Since I have 2 of the same number, yeah, so what can I do with that? Yeah, so where do I put that 5? So I'm going to put my answer right here because I got no room. So what can I do with this? Can I pull it out? Does it stay underneath? What do I do with it? How many 5s do I pull out? 1 of them or 2 of them since there's 2 5s? You have one group, so you pull out 1 5. Think about how many groups you have of 5. What was already on the outside? 12. So those are both on the outside together. What's left underneath the radical that we did not use? All the way at the end. 3. So where's he going to stay? Underneath the square root. And then what am I going to do to simplify this? Ugh, what is 5 times 12? Yep, 60. If you don't do it the factor tree method, remember you see what square divides this? And I would think 25 times 3. And then you go, oh, the square root of 25 is 5, so it would still give you that answer. You would still have 3, and you would still bring down your 12. It would still give you the same work, no matter which way you did it. Do you want another one like this? You want to move on to some variables? Okay. How about the square root of 88 m to the third p squared r to the fifth? So no matter which way you do this, we always mess with the number first. Now, if you like to do the squareds, what squared number divides 88? Not a very big number, sadly. 4. 4 is actually the only one. So I can rewrite this as the square root of 4 times what, 22? Okay. Now, what do we do with the m's? How do we break down variables again? So if they're even, we can pull all of them out, right? Yeah, so since there says there's 3 of these m's here, right? We say, since there's odd, we're going to have, I make another radical over here and go, I'm going to have an m left over. If I take one m out of here, how many's left? 2. Can I divide that by my power on the outside? What's 2 divided by 2? So I got a whole m, don't I? What about p? Can that be divided right away, or do I have to save some? I can save some. How many p's am I going to pull out? Remember, you divide it. 1 p. R's. Do I have to save any r's? Yep, I got to save 1. How many's left over if I pull one out? 4 of them. What is 4 divided by my outside number? So I'm going to have r squared. Okay, so we did the p's, we did the numbers. The only thing we didn't think about is that special rule. We have to simplify the numbers, but our special rule with powers. If it starts even underneath but ends odd on the outside, what goes around our variable? Absolute value. Do any of our variables start even in here and end up odd? The p does. So my p is going to have an absolute value. So now we're going to mix these together, put the variables and numbers together. Can I take the square root of 4? Yep, it's 2. Now, since that's a whole number, can I take the square root of 22? So I use this. I'm going to cross it out so I can keep track. Now, everything else that goes on the outside, I'm going to write it. I have 1m. I have the absolute value of p. I have r squared. Used all those. Now I'm going to write everything underneath. 22 left to right, 22 is in front. So I'm going to put 22 first. Then I'm going to write the variables that are left over. M, then R. And that would be my final answer. Does that make sense, or is that making a little more sense? We just want more practice. We'll do another one. Lex, will you shut my door? Being too loud out there for me today. Okay, how about I wanted one with a bigger number in it. Flip back to see what we got. Okay, how about, I'll make it up. Square root of square root of 36 x to the fourth y to the 6th, z to the 5th. So we look at the number first. Is that number a perfect square, or is it made from it? It is a perfect square, isn't it? It's already a whole number. What's the square root of 36? Okay, whole number already set to go. I got that done. X's, is it even? Okay. When I divide it by my outside power number, how many are left over? 2. So I have x squared. Since it started even, we're good. And it ended even, so we're still good, right? Y's, can I divide them, or do I need to save some? Then just divide. What is 6 divided by 2? So I have y to the 3rd. Is there anything special about that one? So what do I need to do? Absolute value sign on that guy. So you use both of those. All right, now I got no square roots. Now z. Can I pull all of those out somehow? Do I have leftovers? I'm going to have leftovers, so I just need one little square root. I only ever save one variable with variables. If I take one out, how many's left? 4. Then divide it, you get z to the 2nd. Does that one need an absolute value sign on it? No, because it started odd. Getting easier? The more you practice it, right, easier it gets. Good, good, good. Okay, now we're going to incorporate it, and then we'll do some fractions. Do fraction numbers, and then maybe we'll throw some variables in there. Okay? Okay, how about the square root of 45 over 10? Start there. What do we always do first when we have square roots of fractions? Do you remember? You're two ahead, Kimber. You do something first. Yep, separate them. So you get square root of 45 over the square root of 10. You always separate them first. Then, Kimber, what do? Yep, multiply the top and the bottom by the denominator. Now, what does that do to the denominator? And what's only left on the bottom? What number's left on the bottom? Just a 10. Because remember, we showed that this really turns into the square root of 100, and the square root of 100 is 10. What happens up top? Yep, it turns into a big number, 450, right? Now, what are we going to do with that big old number? Huh? We want to simplify this, right? Because it's a big number. So lots of ways we can simplify it. You can break it down by its squares, or you can factor tree. Either way, you're going to break it down. So that one, it's going to stay over 10, right? But this can turn into what squared times what squared root? Oh, my phone is killing me today. Ooh, it's got a lot. It's got a couple squares in it, actually. See, this is one I would use a factor tree for because to me, I personally would be faster at it. Because I would always break it back to my numbers I had, and then it would be quicker. But what can I try? I'm going to go over here. Oh my goodness. Never this popular. I don't know what's going on. Actually, not during the school day. God bless. It died. There's just never enough room. Did you get, before you simplify it, did you get this? Did you get that? Now, what's special about 15 and 10? They're both divisible by 5, right? They're both whole numbers, so that means we can simplify them. So that means the final fraction, we can simplify. The square root always stays the same, and then we actually divide them both by 5, sorry. So that's 3, and that's 2. So this one is actually your final simplified answer, because the whole numbers can be simplified. And right in your calculator, you can just type in, forget the square root, because you're only looking at the whole numbers. You can literally type in 15 over 10, enter math fraction. It'll tell you if it can be simplified. You just never type in the square root, because the square root is not the same, right? A whole number is different than a square root number, so they cannot be in the same group. How was this? Was this so bad? A little bit? Okay, well, 450 is a big number. Okay, let's try some more. Just erase these words. It just takes up space I don't have. Okay, how about, let's try 2. So the square root of fraction. Let's do 2 over 14 and then times the square root of the fraction. Let's do 12 over, I don't know, 3. No, because that makes a whole number, not 3. 5. I had to pick a number that didn't divide 12. So these are two separate fractions. So what do we do first? Combine them and make them one whole fraction. You just do top times top and bottom times bottom, because they're just fractions. With fractions, you still just multiply. And at the same time, you can also separate the square root. So the square root on top is 24 all over. The square root on the bottom is whatever 14 times 5 is. Huh? 70? You sure? Okay. I have faith in you, mostly because I don't know where my calculator is to double check, and I don't have the energy. Okay, now we have a fraction, and I already wrote my separate. Again, how do we get rid of a radical on the bottom? Because we're not allowed. Yep. Multiply everything by the denominator. Denominator just turns into 70. What's a numerator? That's going to be an ugly number. Chewy. See, and this is why I like the factor tree method. I'm not doing that. I just don't have the energy. Cool. For such a big number, it doesn't really divide well. Yes, ma'am. The factor tree way? Yeah. What's left over? 3, 7, and 5. 3 times 7 times 5. See, to me, the factor tree way is faster if you don't know the numbers well. Because you could always go back to what made that and then break them down. Because guessing and checking, you're like, oh, well, 4 worked. You're like, 4 works. Okay, 16 worked. It's got to be a bigger number, right? Because you assume it would be because that's a 4-digit number and really nothing worked. That is why me and the factor tree, we're good friends. We hang. Go to Target together, you know. Smell candles at Bed Bath and Beyond, you know. The good stuff. But like in small numbers, right? Easier just to do the squares. So it's just a preference thing. You're seeing where I'm coming from? Did anyone else try the factor tree method? Because it was bigger? Okay. Well, not ever. The only person who was on my side yesterday was Ava. That's why I asked. Okay. Now let's try some variables in here. Usually the numbers are nicer. Also, I made that up, so you know that's why it was awful. So I apologize about that. Okay, how about the square root of fraction, let's say 32 over y to the 6th. Still, every time, what do you do first? Separate them. Now, I'm going to give you a hint, okay? With variables, sometimes they're already easily done. So before you do the hard work of multiplying the top and bottom by the denominator, look at that variable and see if it can be easily rooted and there'll be nothing left underneath. So aka if this is even, you don't have to do all that work. Is that number even? So when we solve normal roots, how many y's would be left over on the bottom? 3. So we just have y to the 3rd. So the denominator already simplified for us. We didn't have to do all that extra square root crap. And then the 32, square root of 32, can we simplify that? Can that be broken down by a squared times something? For sure can. I already know it in my head. Sixteen and 2. So square root of 16 times the square root of 2. What's the square root of 16? 4. And then we still have the square root of 2 left. So when you have variables, that was a little thick of a 2. But when you have variables, sometimes the best thing you can do is check them before you do all that extra work, okay? Because one of your homework problems was probably hard for you, but actually easy because you didn't even see that. Now let's do one where there's an odd one. And I'll show you another way you can do it. Okay? Now, how about the square root of 8 over, let's say, x to the 5th? Why not? Again, separate your friends. Now this one, it's odd, isn't it? Now there's technically still 2 ways to do this. Okay, you could simplify first if you wanted to. You could simplify the denominator first, or you could wait until the end to simplify. I say if the bottom doesn't work right away, I would just wait until the end so you don't do too many things and confuse yourself. So how do we get rid of a radical on the bottom? Multiply it by itself. So then on the top we have square root of 8x to the 5th now, all over x to the 5th. Bottom's good for us. Can we break down the number 8? Is it a squared times something? 4 times 2. So the square root of 4 is 2. Still have a square root of 2 left over. The x's, it's odd, yes? So we're still having an x underneath, don't we? Then we'll have 4 left over. When I divide out, how many will be whole and on the outside? 2 of them. And then we bring over our denominator. Last step, can you simplify the top and the bottom? This is like 7.2. If you have the same variable on the top and the bottom, what do you do with their exponents? Subtract them. Which one's greater, 5 or 2? What's 5 minus 2? Where's that answer going to go? Bottom. X to the third. 2 square root of 2x, because that x is not in the game with everybody else because he's underneath. That one's just like the 42 that you did for homework, just different numbers. Which is why we had to learn 7.1 through 7.3 before we could do this, right? Because if not, we'd be sure out of luck, for sure. Right. Is it making more sense than it did? Okay. Good, good. I'm happy. Which means, now that we understand this, we can keep going. So what we're learning today is still 7.3, because we only did half of it yesterday. Legitimately half, which was, at least it was even. And now we are going to learn the other half. Sadly, we still have to do some fractions. I'm sorry about that. Okay, now, first thing I have a vocabulary word for you. So if you want to write on your paper, you can just write 7.4 continued if you want. Okay, first thing you have to learn about is conjugates. Conjugates. Oh, I always spell it wrong every time. J-U-G gates. There you go. Conjugates. That's how it's spelled. Okay, so a conjugate, they're used with radical binomials. Okay, this is what it is. So if we have, and they give you all the letters for this, a square root of b plus c square root of d. Then its conjugate, which really, put in parentheses, means its opposite. This is how we get rid of binomials in the denominator. So if we don't just have a radical, but have something plus something else. Its conjugate is going to be a square root b minus c square root d. So the only difference is you just change the sign in between them. And then you're going to have to multiply. Well, come back and think about it. If you have two terms multiplied by two terms, right? You're used to seeing them like this. How do you multiply two terms, two sets of things? Yep, you have to FOIL them. So you will be foiling. Okay, so a little hint, using FOIL. Most of the time you don't have two square roots. Most of the time you only have a number minus a square root. It's usually not that crazy. Okay, I'm gonna move this. Okay, so for example, 3 all over 5 plus the square root of 2. So we're not allowed to have radicals in the denominator, which is why, come on, we need the conjugate. So we're going to take the top and the bottom, and we're going to multiply them by the conjugate only of the denominator. So we're going to multiply top and bottom by 5 minus the square root of 2. 5 minus the square root of 2. Now the top, you're really just going to distribute. So 3 times 5 turns into 15. Now, can you multiply a whole number times a radical number? No. What number is technically outside this right here? 1. So when you take 3 and multiply it by this radical, you're really doing 3 times negative 1. So this will turn into minus 3 radical 2. Now, same thought process when we do the bottom. Foiling. First times first, so 5 times 5, 25. First times last, you have negative 5 square root 2. Inside times inside, positive 5 square root 2. I always need a longer than a half. And then last times last. A positive times a negative is a negative. Square root of 2 times the square root of 2 is the square root of 4. Since they're both under square roots, you can actually multiply them. I know it looks really long, but they will cancel out. What do you see right here and right here? So they're exactly the same, but one's positive, one's negative. What happens if I have $5 and then I have negative $5? They cancel out, and how many dollars I got? I got nothing, right? So these always, every single time, will cancel out. So we're almost done with all our radicals. So then I'm just going to simplify this because it's a really long list. And then 25 is still just the number 25, isn't it? This still says minus. Do we know what the square root of 4 is? The whole number 2, yes? It's a whole number, isn't it? So by doing that complex conjugate, which is the inverse, do we have any more radicals on the bottom? That's what we wanted, isn't it? Can we do this basic math right here? We can. $23. And that's it. On another positive, they almost never give you variables. It's always just numbers. Okay? The other thing is, and this is, I think, probably the scariest part of everything is, the last thing you would do is, you remember how on the last problem, you would look at the whole number, you only ever had one, you would look, say, do these have anything in common? Right? Now you have to look at all three. 15 and 3 and 23. All three of them have to have a number column in common to pull something out. Well, 23 is an odd number. It's not just an odd number, it's a prime number. So is it going to have anything in common with 15 and 3? So this is as simplified as it can get. But if this 23 would have been a 20, or not number 20, I was trying to think of something. If it was 24, not 23, they'd all have something in common. They'd have the number 3 in common, right? So you still might have to simplify whole numbers, okay? We're going to do another one, or another one, and another one, and another one, okay? Okay, we just did a one that started with a plus. Let's do one that starts with a minus. 7 on top. Let's write so big by accident. 3 minus the square root of 7 on the bottom. I always put the bottom in parentheses. If not, I sometimes forget to FOIL. So what are we going to multiply the top and the bottom by? Yes, 3 plus this time the square root of 7, because you have to see what you already had. If you don't do the opposite, they're not going to cancel out. So the top you're going to distribute again. When I distribute, what am I going to get on top? Mm-hmm. It's just weird because they're the same number, isn't it? It's okay. 7 square root of 7 is correct. Now in the denominator, when we FOIL, what do we get for F when we FOIL? First times first. Yep, 9. What about O? Outer. Oh, yeah, but what's the answer? Nope. Outside times outside. Plus 3 square root 7. Inside times inside. Yep, negative 3 square root 7. And last, yep, negative square root 49. Yes. Why? Because you know every time the 2 inside cancel out, don't they? If you can make that connection, you can skip that step. Yes, sir. You can. Just don't always do that every time you FOIL, because then you're really going to, kick yourself in the butt for that later. Okay? So yes, you can just do firsts and lasts together, because these always cancel. So you're left with 21 plus 7 square root 7 all over 9 minus what? 7. What's the denominator simplified to? Can I simplify my whole numbers? No, because my denominator is a even. Nothing else is. How was that? This was like your chapter, though. You're doing pretty good. You and Camry both. You guys are always funny because the things that other people find hard, you don't find hard. You guys are weirdos. Okay, now on a positive, we got no more variables. Okay, and we're gonna stop doing fractions. We're gonna go back to just radicals, but we're gonna throw in some addition and subtraction. Next little title is called Operations with Radical Expressions. I'm abbreviating it so I can fit it on the line. We're gonna start with the easy stuff. So, start 1. 5 square root 2 plus 7 square root 2. I wrote a 7 because I'm an idiot. Minus 6 square root 2. What do you notice about all 3 of these numbers? Huh? They all have the same radical. It's kind of like variables. When variables all have the same, when numbers have all the same variable, like if these were all x's, what could you do with all these numbers? You can combine them. So you ignore the fact that it's square root 2, you just write it down, and you just do the operations with those numbers. So what's 5 plus 7 minus 6? 6. That's it. Simplify each expression. Done. Does that make sense? So you cannot add things unless they're radicals, which is like terms, unless they're the same. Right? Eventually we'll have to make them the same, but we're starting off slow. Starting off easy. How about this guy? 10 square root 7 plus 5 square root 11 plus 4 square root 7 minus 6 square root 11. Almost ran out of room on my board. Now with these ones, what are we going to do? Yep, do the 7s, add only the whole numbers together, and then take the 11s and add only their whole numbers together. So I got what square root 7 when I'm done? 14. And then am I going to put plus or minus? Minus. And then do I have a number? Technically it's 1, so do I have to write it? Nah. Square root 11. Do you think the order really matters? With which, if I put the square root of 7 1 first or the 11 1 first? It doesn't. As long as, I just saw someone look at my door. Did anyone else see that? No, Lauren? Okay. Out of everyone, Lauren's the only one that might have seen it. Maybe Kimber. Everyone else is in the wrong seat. Someone just jumped to try to look at my room. I don't know. It would not matter if I would have wrote negative a square root 11, then plus 14 square root of 7. These, it does not matter, okay? So as long as you make sure the signs are the same, the order does not matter, right? Because addition, subtraction, as long as you have your signs right, you're fine. Okay, just putting that out there. So if I read something to you for correctness on homework and stuff like that, it'll be fine. Okay. Next, let's try when the numbers aren't as simple. The good thing is they're always just double digits if it gives you any kind of hope and joy. Okay, how about 2 square root 18 plus 2 square root 32 plus the square root of 32. Oh, 72, sorry, not 32. I'm losing my mind. Losing my marbles. So we got 2 square root of 18 plus 2 square root of 32, and then plus the square root of 72. Well, right now, can we combine anything? No. So that means we're going to want to look at each one individually and say, can this number be simplified and rewrite each radical and just keep them in the spot they're in? So this, we still have a 2 on the outside. Can I break this down into a squared times a number? Yep, 9 and 2. Square root of 9 times square root of 2. I would just break them all down so you're in the same mindset all at the same time. Have a whole number again. Can I break down the number 32 into the biggest squared times something? Yep, 16 times 2. Then plus again, there's no whole number already. 72. 9's not the correct answer. There's a bigger one. $36 and 2? Okay, so now let's go through and turn everything that can be a whole number now into a whole number. So now this is going to turn into what? The first one. Remember, square root of 9 is what number? This is 3. What operation is this when they're right next to each other? So this turns into 6 square root 2. Keep the plus sign. Square root of 16 turns into what number? 4. Multiply it by its 2. You have 8. What's left over? Square root of 2. I almost wrote 8 again. Then plus, what's the square root of 36? Square root 2. Now when I look at all these, other than this one because it's ugly, what do these numbers have anything in common? Yeah, they all have the same radical. So now can I turn them into one big radical? Okay, what is 6 and 6 and 8? Does that make sense? Now that we understand how to do the radicals? Sometimes all 3 of them won't add. This is just luck. Sometimes 2 of them will add and you'll just have another one. He just square root of 3. He's just sad and lonely and you just bring him down. Okay? Sometimes they don't all add together. Okay, let's do another one. Sometimes you simplify them and they never add together. Sometimes you never know. Okay, how about, we'll just do one more. How about 4 square root of 54 plus 2 square root of 24. I got 2 of them this time. So let's break them down. What 2 square roots make 54? 27's not a squared, sweets. You're thinking 4, 9 times 6. Yep, so 9's a squared, so I put it in front, and then a 6. Then plus, and 2. 24 should be easy. Hopefully those ones you can think in your head. Which ones of the groups is a squared? 4 and something. 4 and 6. 8 and 3, 4 and 6. 12 is not a squared. If it makes you feel any better, I didn't hear you. So then, square root of 9 is the whole number 3. Right underneath. Square root of 4 is the whole number 2. What do you do with the whole numbers? Multiply them. So 4 times 3 is 12. There you go. There it is. Then square root of 6 plus what's 2 times 2? 4. Again, square root of 6. Can those be added together? Yeah, what's my final answer? 16 square root 6. Better? Not so bad? Okay, we did adding and subtracting. What's our next operation? Multiplying. I don't think we do. We already did dividing, so dividing's over. Multiplying is all that's left. Let's start with the lowest or basic of the forms. 3 square root 2 times, give you a little dot, 2 square root 6. I've already done this, basically. When you have two things next to each other, what do you do first? Basically the question I gave you when we first started this. Huh? Combined your like terms. So what are we going to do first? 3 times 3 times 2 is 6. What am I do with my radicals? Am I also going to multiply them? Yes or no? Yeah. 2 times 6? 12. Can you break down the number 12? Yes, ma'am, you can. 6. And then 12 is what squared times what? Remember, it has to be squared. 4 and 3. Square root of 4 is really what number? 2. So what's your final answer? We have the whole number 6, the whole number 2, and then we had this radical 3 left over. Yep. 12 square root 3 is the final answer. Easy peasy, lemon squeezy? Yes? I haven't said that statement in a long time. Okay. And then anything much different about this? 3 square root 5, parentheses, bless you, 2 square root 5 plus 5 square root 3. What does this guy ask us to do? We have to distribute. When you distribute, you can still only multiply like things, right? Whole numbers times whole numbers, radical thingies times radical thingies, right? So when you distribute the first time, what are you going to get? 6 square root 25, and then plus what? Yeah, 15 square root 15. That was real weird, isn't it? Then once you're done, you take a little eyeball check and go, can I simplify any of this? Yep, what can I simplify, Kimberoon? 25. What we can do with this 25? Yeah, what's the square root of 25? Is it a whole number? It is. So this is 5. We already had the 6. What number does that turn into? 30. 15. What is the only two numbers other than 1 and 15 that make 15? 3 and 5. Are either of those prime? I mean, are either of those squared numbers? No, so can 15 be broken down? No, so this guy is just drug down next to the answer. So this one, that is the answer. Because you could not simplify the square root of 15, and they cannot combine like terms. So that's all we have. And I would just keep them in the order they're in. Make sense? And then, I think, last but certainly not least, your favorite, where you actually have to do all 4 steps. You gotta do the foily doilies. Okay, let me give them to you. How about 5 square root 2 plus 3 square root 5? That's your first set of parentheses. Second set of parentheses, 2 square root 10. Ooh, minus 5, whole number. Throwing you for a loop now. Again, we're going to FOIL. Do we have to do all the steps of FOIL this time? Yeah, because all those numbers and things are different. So make sure you pay attention. First times first. Whole numbers times whole numbers. Radicals times radicals. 20. Yep. Then a plus sign. Not a plus sign. I was ahead. First times last. Whole numbers times whole numbers. Negative 25, because that 5 is negative. This radical, does it have anything to multiply by? No, so what do we do with it? We just bring it down with it. So radical 2. Okay. Next, inside times inside. Plus 6, and then square root of 50. I'm not going to have enough room because I write too big. And then last times last. Negative 15, and then I have to bring down that radical, don't I? Oh, Miss Rinaldi, you write too big. Now, we got to look at them. 20, can that number 20 be broken down? Yes, because it does have radicals. This is just in my way. I'm going to make it real small. There we go. Okay. 20, bring down the 10. 20 can be broken down into what radical times what radical? 4 and 5. Yep. Can I break down this? Can I break down the number 2? Heck no. You just bring it down. Okay. What about 50? Can we break down the number 50? Oh, yeah, for sure. What two things? What's the biggest square that goes into 50? Oh, 25. And then can we break down the radical of 5? The number 5, can we break it down? Nope, it's a prime number, so we have to bring that down too. Which is a good thing because I got no room. Now, do you see things? Let's simplify it first. Let's turn these things into whole numbers that need to be. Square root of 4, is that a whole number? 2. Can we simplify the whole number times the whole number? 20. I'm left with square root 5. So 20 square root 5. This guy, we didn't do anything to him, right? So we're just going to bring him down again. What about the next one? What radical can we simplify? That turns into 5. When I multiply my whole numbers, what do we get? 30. And then I have square root 2. And then we couldn't do anything with him, so we bring it down. Are we done? I'm almost out of room, but are we done? Now what can we do last? Combine our like terms. We got a square root of 5 here and a square root of 5 all the way at the end. What's 20 square root of 5s minus 15 square root of 5s? 5 square root of 5. Anything else we can add together? The 2's. How many square root of 2's do I have left? Is it positive or negative? Positive. 5 square root of 2. Look at that. If only I wrote smaller. That is a simplified answer. Again, would it matter if my 5 square root of 2 was in front of my 5 square root of 5? It would not. Does this make more sense today than it did yesterday? Are you glad we did it in 2 days instead of one? Could you imagine all this at once? Okay, well that's good because it's 1:57. Practice these. So because we had to extend the day, we'll either have to smush next week or you're going to lose a review day from me, which might happen. So we'll have to work on it. But